guys, hi, welcome back. So in the previous video we have seen 7 questions, right? And in this video we will see the 8th question and the 9th and the 10th. Okay, 3 questions. So these questions we know these are related to the Coulomb's law. Okay, so let us see the 8th question. So the 8th question is 2 point charges plus 9e and plus e units are placed at a distance r apart. Find the position of third point charge so that it is in equilibrium. So here it is said you have two charges, one is plus 9e, the other is plus e, and they are at a distance r apart. That means the separation between them is r, right? And then it is said that you are placing a third point charge. Okay, you are placing a third point charge such that it is in equilibrium. Okay, and you need to find out the position of that third charge. Clear? I hope the question is clear. Now we will draw figure related to the question. So here if I take this is plus e charge, this is the plus e charge. Okay, and at a distance r I'm placing another charge plus 9. Okay, this is what it is mentioned in the question, that you have two charges, one is plus e, other is plus 9e, right? And they are at a distance r apart. And now in the question it is said you are asked to place a third charge. I'm taking the third charge to be capital Q, suppose. Okay, this charge Q we will place somewhere, okay, somewhere such that this charge is in equilibrium. Okay, that is, it is not moving. So here if you see in this particular case, this is the first charge, this is the second charge. This charge will experience a force, right? Force on charge 1 due to the charge 2, due to this charge. That is a repulsion. This charge will be repelled by this particular charge. Similarly, this charge will be repelled by the first charge. So F2 1. That means force on 2 due to 1. These things we have studied in the Coulomb's law. Now, if you see here, if you place this particular charge outside, okay, in this region or this region, it will be not in equilibrium. In order to be in equilibrium, okay, this charge Q must experience a force on this side also, on this side also, opposite side. So I'm placing this particular charge somewhere here. Okay, why I placed here, that you'll understand. This is the position of Q, suppose. Okay, and I'm taking this distance to be L from this particular charge E. Okay, I'm taking it to be E. Now, if you see in this particular case, this charge Q will experience force due to the charge 1. That will be repulsion on this side. Similarly, it will experience force on opposite side also, because this is a positive charge. This is also positive charge, so it will repel. This is force on Q due to the second charge. This is force on Q due to the first charge. Now, if you see, the magnitude of this charge is more than this. So I have placed this charge, this particular positive charge, close to the small charge, right? Okay, it is close to the charge which is having small magnitude. Why? Because it's only then it will be in equilibrium. If you place this third charge close to the charge which is having high magnitude, it will experience more force, okay, due to the second charge. So always whenever you will have both the charges of same nature, then you will place this particular charge, okay, between them, so that the third charge is in equilibrium. And you will always place near the charge which is of small magnitude. Clear? So now I think the question is clear. We just need to calculate the value of what? The position. That is, we need to calculate the value of small l. Okay, this L. We need to find the value of L. Okay, here. Now you see, by Coulomb's law. Okay, we will calculate by Coulomb's law. So first of all, here net force must be equals to 0. Okay, on this particular charge Q. So for net force to be equals to 0, force on charge Q due to the charge 1 must be equals to the force on charge Q due to the charge 2. Alright. Now we will use the Coulomb's law. We know the Coulomb's law is what? K, that is 1 by 4 pi epsilon naught, product of the charges. So this charge is Q. The first charge is having the magnitude to be E. And the distance between Q and E is L, right? So this will become L square equals to, here again K, the charge q is same. The magnitude of the second charge is 9e divided by the distance between this q and this 9e. So if you see here, this entire distance is r, this distance is l. So it will be how much? This distance will be how much? R minus L. Okay, this entire minus with this length. Okay, so you write here R minus L whole square. So if you see here, in this case, KQ will get cancelled. Sorry. In this case, this K will get cancelled with this K. This Q will get cancelled with this Q, right? And this E will get cancelled with this E. So what you will have here is R minus L, I'm taking this side, by L whole square by 9. 9 can be written as 3 square, right? So when you will equate the power, you can write R minus L is equals to plus minus 3, okay, L. Clear? So from here, R you can write plus minus 3L plus L. Okay. So from here you can write either you can write R is equals to what? Plus 3L plus L or minus 3L plus L, right? So plus 3L and plus L will give you what? R is equals to 4L. That from here you can get L is equals to R by 4. And from here you will get R is equals to minus 2L and L is equals to minus R by 2. So here if you see this minus R by 2, you will ignore because this distance will come to this side, opposite side, where we cannot place this charge. Because in this side, this minus R by 2 is that distance at which if we will place the charge, it will be not in equilibrium. That is on this particular side. So we will take R by 4. That is because we know we must place the charge between the two charges so that it is in equilibrium. Okay, so we will consider this to be R by 4. Now you see, it is given from the answer L is equals to R by 4. This distance L is from the charge plus E. Okay, this distance of the charge, this position of the charge is from the charge 1, that is plus E. Again, if you are asked to calculate from plus 9E charge, okay, so from plus 9E charge, you can write the distance in other way also. How you will do? You will just write R minus L. L is what? R by 4. So you can write 3R by 4. Okay, so this is the distance from plus 9E charge and this is the distance from plus E charge. So this is how you can calculate. So the concept is easy and clear. You will have to just check that in what condition and on placing where the charge will be in equilibrium, and just use the Coulomb's law, the net force and all these things. All right. Now let us see the next question. It is said dielectric constant of a medium is unity. What will be its permittivity? So we have studied about the dielectric constant, about the permittivity of free space and all these things. Okay. So here in the question, what is given to us is the dielectric constant. We know how we denote the dielectric constant. We write the dielectric constant as K, right? So here it is given K is equals to 1. What it is given? K is equals to 1. So you will have to say what is its permittivity. Permittivity means you need to calculate epsilon. Okay. So we know that K is equals to epsilon by epsilon naught. This is permittivity of the medium. This is the permittivity of the free space. So here, in order to calculate epsilon, we can write it is epsilon is equals to K epsilon naught. And we know permittivity of free space, it is having value 8.854 into 10 to the power minus 12, right? This is the value. So we'll just put this is 1 into 8.854 into 10 to the power minus 12. So you can write epsilon is equals to 8.854 into 10 to the power minus 2. Clear? So this is the permittivity when your dielectric constant of any medium is unity. Clear? So this was an easy question. Now let us see the next question. Question number 10. Here it is said 2-point charges Q1 and Q2 are 3 meters apart and their combined charges are 20 microcoulomb. That means you are having two charges Q1 and Q2 and its sum is given 20 microcoulomb. If one repels the other with a force of 0.075 Newton, what are the two charges? So both the charges are positive because the force between them is repulsion. and the value of the repulsive force is given to you. The distance between the two charges is also given to you. You just need to calculate the magnitude of the charges. So directly you can just draw a figure. This is your Q1, this is your Q2, and the separation between them is R is equals to 3 meter. So we can just use the Coulomb's law directly. So first of all, let us see the sum given is Q1 plus Q2 is equals to 20 microcoulomb. So from here we can write Q1 is equals to 20 minus Q2. Okay. This is what it is. R we know. The force F is also given. So directly we will write in the entire all the values in the Coulomb's law. Okay. Coulomb's formula. So by Coulomb's law, what we have the formula? We have the formula F is equals to K into product of the two charges divided by the distance between them. That is R square, right? So the value of force is 0.075. We know K can be written as 9 into 10 to the power 9 into Q1 and Q2 once I am keeping as it is, and this R square will become 3 square, that is 9, right? So this 9 and this 9 will get cancelled, and from here this 0.075 can be written as 75 into 10 to the power minus 3, and this can be written here as 10 to the power minus 9 when you bring it to the opposite side. This is Q1, Q2. Now I'm rearranging it and I'm writing Q1, Q2 is equals to 75 into 10 to the power minus 12. Okay, this will become Coulomb square. Okay, so here this Q1 can be written as 20 minus Q2 into with Q2. And this can be written as 75, 10 to the power minus 12. So 10 to the power minus 6 minus 6. We can write it as microcoulomb square. Alright. So from here, we'll just do the multiplication, right? 20 Q2 minus Q2 square equals to 75. So here what we will do is we can write Q2 square minus 20 Q2 plus 75 is equals to 0. Now we will do the midterm splitting. So we can write Q2 minus Q2. This is square, okay? And here it is plus 75 equals to 0. We know we will have to do plus only, okay? We'll have to do plus because here the sign is plus. So it will be what? 15 plus 5 is 20 and 15 5 is 75. So it is 15 plus 5. So simple. Q2 square minus 5 Q2 minus, okay, minus 15 Q2, okay, minus 5 Q2 plus 75 equals to 0. So you can write here Q2 taking common. This is Q2 minus 15. And take minus 5 common. Again, you will have Q2 minus 15 equals to 0. So from here you can write Q2 minus 5 is a factor. And next is Q2 minus 15 is a factor. So either you can write out of this Q2 can take the value to be 5 or Q2 can take the value to be 15. And Q1 can be, if Q2 is equals to 5, then Q1 will be equals to what? 20 minus 5, it will be 15. Or if your Q2 is 15, then Q1 will be what? 20 minus 15, that is 5. Okay. So either of the solutions you can consider. So these are the value of the two charges. Clear? So this was a very easy question. So that's all in this video. Thank you so much. Have a good day.